The wind hits before you see it coming. One moment the steppe stretches calm beneath a sky the color of bruised iron. The next, a wall of grit and ice crystals slams into your face, stinging your eyes until tears stream sideways. Your animals bunch together, heads low, and in that instant you understand something that modern travelers rarely grasp. You have perhaps 90 minutes before hypothermia becomes a real possibility, and everything you need to survive is strapped to the backs of animals now shifting nervously in the rising gale. This is not a scenario from adventure fiction. This was ordinary life for countless nomadic peoples across grasslands, deserts, Arctic tundra, and mountain plateaus, communities who could not call for rescue, could not retreat to permanent structures, and could not afford to get shelter wrong. The question that haunts anyone studying these cultures is deceptively simple. How did they build stormproof shelters in hours, sometimes less, with almost no tools? The answer isn't luck, and it isn't superhuman toughness. It's something far more interesting, a shelter system refined over generations that turns material scarcity into speed, and speed into survival. To understand what made these shelters work, you first need to abandon a modern assumption. We tend to imagine building as a slow process requiring blueprints, specialized tools, and construction crews. Nomadic shelter traditions inverted that logic entirely. The brilliance wasn't in the building moment, it was in everything that happened before the storm ever appeared on the horizon. Components were pre-made, standardized, and designed for rapid assembly by people who had rehearsed the same motions since childhood. A yurt of the Central Asian steppes, known as a jur in Mongolian tradition, didn't require cutting, measuring, or improvisation during setup. The lattice wall sections, called khana, were pre-built frameworks that collapsed flat for transport and expanded accordion style when needed. The roof poles were already shaped, smoothed, and fitted to a central compression ring. The felt covers were already cut and sewn to precise dimensions. When a storm approached, the question was never, how do we build this? It was simply, how fast can we deploy what we already carry? This distinction matters enormously. Speed came not from rushing, but from eliminating every task that could be done in advance. The assembly wasn't construction, it was choreography. But here's where things get more complicated, because not all nomadic shelters followed the same logic. The Bedouin black tent of the Arabian Peninsula and North Africa operated on entirely different principles than the yurt, yet achieved similar storm resistance through opposite methods. Where the yurt was rigid, round, and compression-based, the black tent was flexible, rectangular, and tension-based. Woven from goat hair, often the hair of black goats, which gave the tents their name, these coverings performed a trick that seems almost counterintuitive. They tightened when wet. As rain or humid air hit the fibers, the weave contracted, becoming more water-resistant precisely when water resistance mattered most. The tent's low, sloping profile allowed wind to flow over rather than catch against it, and the entire structure could be adjusted throughout a storm by loosening or tightening guy ropes. In the Arctic and subarctic, the Sami Lavu, a conical tent supported by wooden poles arranged in a tripod and covered with hides or textile, used yet another approach, channeling smoke upward while shedding snow loads that would crush a flat roof. Each of these traditions solved the same fundamental problem, creating a survivable microclimate under hostile conditions, but did so with the materials and weather patterns specific to their environments. There was no universal method. There was, instead, a universal understanding. You cannot fight the storm, only redirect it. The physics of stormproofing is less mysterious than it first appears, though mastering it required generations of trial and refinement. The first principle was profile. Low, curved, or sloped structures presented less surface area to the wind and fewer opportunities for gusts to find purchase. A tall, vertical wall catches wind like a sail. A domed or conical shape lets it slide past. The second principle was flexibility. Rigid structures can be strong, but they resist force until a breaking point, then fail catastrophically. Flexible structures absorb and redistribute force continuously, bending without snapping. The lattice walls of a yurt could flex slightly under pressure, and the felt covering stretched rather than tore. Black tents billowed and shifted, their guy ropes acting as shock absorbers. Lavu poles could shift at their crossing point, adjusting angles under snow load. The third principle was load path, ensuring that forces traveled through the structure in predictable ways and ended up in the ground rather than in vulnerable components. A yurt's compression ring wasn't decorative. It was the keystone that turned a cluster of roof poles into a unified dome, transferring the weight of felt and snow downward through the lattice walls into the earth. Ropes and pegs weren't afterthoughts. They were the anchors that prevented uplift in gusts that could approach hurricane speeds on the open steppe. Every component served a structural purpose, and that purpose had been tested in countless storms before any single family ever raised their home against a darkening sky. Materials were never random, though to an outsider they might have seemed merely available. Felt, the matted wool fabric used across Central Asia, was chosen not just because sheep were plentiful, but because felt possesses properties that woven textiles cannot match. Its fibers trap air, creating insulation, even when the material is compressed against a frame. Critically, felt sheds wind rather than allowing it to penetrate, and it retains warmth even when damp, a property that could mean the difference between survival and hypothermia in a storm that brought sleet or freezing rain. Goat hair, used in black tents, was selected for its behavior under moisture, that counterintuitive tightening that sealed gaps precisely when sealing mattered most. Hides were valued not only for their durability, but for their flexibility at temperatures that would crack lesser materials. Wood, scarce across many nomadic environments, was hoarded, repaired, and transported hundreds of miles rather than assumed to be findable along the route. The wear patterns on surviving historical poles and lattice joints tell a story of objects used for decades, sanded smooth by hands that had assembled them thousands of times. Ropes and straps were made from sinew, horsehair, leather, or plant fibers depending on the region, and spare lengths were always carried because a snapped line in a storm could doom the entire structure. The repair kit was as essential as the tent itself, not because failure was expected, but because failure was understood to be possible, and possibility demanded preparation. Here's the twist that doesn't appear in most romanticized accounts. The biggest secret of nomadic shelter building wasn't strength, materials, or even design. It was social choreography. One person alone, even a skilled one, could raise a yurt, but it would take dangerously long in an approaching storm. A trained group, operating without verbal instruction, could do it in what some ethnographic accounts describe as under an hour, with some communities reportedly managing faster under urgent conditions. Each person knew their role. Children held poles steady, while adults secured lashings. Elders, whose strength might have faded but whose experience had not, read the terrain and directed orientation, ensuring the door faced away from the prevailing wind, that the site offered natural protection from a leeward slope or rise in the land. Animals, properly positioned, could act as living windbreaks, their bodies blocking gusts that might otherwise tear at loose fabric during the critical minutes when the covering was being secured but not yet anchored. The system was human before it was material. Families who traveled together for years developed an almost wordless efficiency, a set of automatic responses triggered by the first signs of dangerous weather. This wasn't instinct. It was training so deep it resembled instinct. Watch duty, drying routines, decisions about when to stay and when to move, all of it was structured, passed from generation to generation, adapted to local conditions but never improvised from scratch. Site selection was so important that many herding cultures considered it half the shelter itself. The finest tent in the world becomes a death trap if pitched on exposed high ground with no windbreak, or in a depression where water will pool and flood the interior. Experienced herders could read terrain the way a sailor reads the sea, identifying leeward slopes where wind velocity dropped, natural berms of earth or rock that would deflect gusts, patches of dense vegetation that might anchor guy ropes more securely than bare soil. In winter conditions, snow itself became a material. Packed drifts could form walls that blocked wind before it ever reached the tent, and in some Arctic traditions, snow shelters from igloos to simpler windbreaks were built specifically to protect the more vulnerable skin or textile tents inside. Orienting the entrance was never casual. Doors faced away from the storm's approach, and in some traditions the rear of the shelter was built with additional reinforcement, specifically because it would bear the brunt of the wind. Animals were positioned with intention, their bodies useful, but their panic, a danger. A frightened horse pulling loose from its tether could knock a partially raised tent flat in seconds, and managing livestock during setup was a task that required calm competence. Nothing about this was accidental. The landscape was a partner, and reading it correctly multiplied the effectiveness of every material and every minute of labor. The logistics of carrying a home deserve attention because they contradict the notion that nomads traveled light in the sense of traveling unprepared. A yurt, with its frame, covering, floor felt, and ropes, might weigh several hundred pounds, manageable only because pack animals, carts, or sleds did the carrying. Camels in desert regions, horses and yaks on the steppe, reindeer in subarctic zones. These animals were not pets or luxuries, but the essential infrastructure of mobile life. The packing itself was systematized. Heavy lattice sections went on specific animals. Rolled felt was positioned for quick access in case of weather. Repair materials, spare pegs, and extra cordage traveled in known locations so they could be found without searching when fingers were numb and the light was failing. Communities that moved seasonally along known routes sometimes cached materials at predictable campsites, reducing what needed to be carried on each leg of the journey. When ethnographers and travelers documented these cultures in the 19th and 20th centuries, they often marveled at the speed of setup, but the speed was an illusion created by invisible preparation. Months and years of preparation that made the visible moment look effortless. This is the lesson that tends to get lost in modern romanticization. There was nothing primitive about these systems. They were mobile architecture, optimized by unrecorded engineers across uncounted generations, surviving because they worked and dying only when external forces, political, economic, ecological, disrupted the way of life they supported. What does it mean to call something primitive? The word carries an unspoken assumption. That older means cruder, that technological progress moves in one direction, and that nomadic peoples were simply waiting for better options. But a yurt that can be raised in an hour, withstand winds that would flatten a modern camping tent, and create an interior temperature difference of 40 or 50 degrees from the outside, air is not crude, it is precisely engineered for its constraints. A black tent that repairs itself in rain through the physics of fiber contraction is not a failure to invent solid walls. It is a solution that solid walls could never provide to a community that must move again in a week. The shelters discussed in this narrative were not accidents of tradition. They were storm technologies as real as any manufactured emergency shelter on the market today, and in some conditions, more effective. They were also social technologies, systems that worked only because communities functioned as coordinated units, because knowledge passed intact from parent to child, and because roles were clear enough that a group under pressure did not waste seconds debating what to do. The storms came without warning. The wind scoured grit into eyes, numbed fingers, panicked animals. And in the space between that first gust and the darkness, people with almost no tools built shelters that kept them alive until morning, not because they were tougher than you or me, but because they understood something about design, materials, and cooperation that modern life has largely forgotten. Their answer to the storm was not survival by luck, it was survival by system.